Hi, class. This will be the last of the recorded lectures for section 4.3. I think everybody's happy about that, including myself. And so what we're going to do is introduce one more set of formulas and show how to use them. And then we will do a couple proofs. So this recorded lecture might be a little longer than the other ones for this section. So let me show you the last of the formulas that we will be dealing with. And this is called the product and sum formulas. So basically giving two trig functions, sines and cosines again, that are multiplied together, you can split them up into product and sum. And I do want you to be aware of, and I'm sure you know this, but remember this equal sign means you can go both ways. So if you're given a sum and you want a product, you can combine it going from right to left or vice versa. If you have a product and you want to convert it to a sum, you could go the other way. So let's do a couple of these examples. Well, let's do one example and then we'll do a couple proofs. So what was the first example? It would be this one here. So if you had 3, say, cosine of 4, and let's call that x, and then cosine of 7x. And the problem basically states take this product and write it as sums. So if you wanted this one, and let me just put it over here. So this would be cosine of u, cosine of v, and that would equal 1/2 cosine of u plus v plus cosine of u minus v. So that's the one that we're going to use. So in this case, the u is going to be 4x and our v is going to be 7x. So obviously we're using that formula. So let's just plug it in and see what we get. So you get cosine of 4x plus 7x, and then you get plus cosine of 4x minus 7x. So you simplify this again, you get 11x here. And what do we have here? Cosine of minus 3x. Typically, you never leave a negative value of the period that we have in there, right? Minus 3. And so the idea here is, remember we had these symmetry properties? That's what I mean. We got a lot of stuff to organize. And if you remember, cosine is actually an even function. And so by using the symmetry properties, whoops, I forgot my 1/2 out front here. Yeesh. All right, glad I caught that because I'm off by 1/2, right? So this would be 3 times 1/2, and this would be 3 times 1/2. Forgot my 1/2 that I have in the formula here. But anyways, back to the symmetry. We can just make that 3/2 now, right? And so that would be cosine of 11x plus cosine of 3x. So that would be the simplest form. And when you do these kind of problems in WebAssign, and for me as well, forgot my S there, I would want you to make sure that you use the symmetry properties to get rid of the negative sign in these calculations and proofs. Okay, so let's do one reasonable proof and then one very challenging proof. See how we go here. So let's do this one. Sine of 3x minus sine of x over cosine of 3x plus cosine of x. And basically that is supposed to equal tan of x. So how do we do that? Well, since we just did the sum and product formulas, we're going to use those, the sum and product. We're going to use it for the cosine, the difference in cosine, and the additions of, or the difference in signs in the numerator, and the additions on cosines. So unfortunately, my whiteboard isn't big enough to write all these formulas in here, but this is what this would look like. So if we have this set up where let me pull up the formulas again. Don't think I showed you these. That's probably why I'm like, So we had the product to sum, right? And now we have the sum to product. And you could see that basically we just moved the two on the other side there with regard to those calculations. And so these are the sum and product. So let me go back here, and we're using the sum and product. So with the sign calculation, that would be the difference, right? Because we have subtracted 2. So when you plug that one in, you have a 2 out front, and then all these end up being cosine. And so this would be 3x plus x divided by 2. And then this one here is the sign, and that would be 3x minus x divided by 2. So where did that come from? Again, that came from these product to sum rules. And let me just show you that again. So when you look up here, we had the minus, so you could see the cosine is first, and then the subtract for the sine is second. So in our denominator, we're going to be using cosine of x, cosine of y. So here we have 2 cosines in this case, right? And so back to the whiteboard. And that's why it's really quite handy to have all these formulas sitting in front of you. So on the bottom, we would have 2 cosine, and then this would be 3x plus x over 2. And this would again be a cosine, and this is 3x minus x over 2. And so there's our first 2 terms. So let's simplify this a little. Well, the first thing we could do is get rid of these 2's. So that's nice. So now we do, as they would say, some algebra on steroids, right? And we have we have cosine of 4x over 2. And then we have sine of 2x over 2. And then on the bottom, we have, again, cosine of 4x over 2 and cosine of 2x over 2. So you can see these are common factors, so you can get rid of those. And then you end up with sine of x over cosine of x when you do the little arithmetic in there. And what does that equal? These are just the basic identities, you could say. It equals tan of x, QED. Okay, see what I mean? Very tedious. So it is super important to make sure you have a good grasp of these formulas, and without memorizing them, you need a nice list of them. So again, I would highly recommend that you either make your own list up, or if you have access to a printer, you can print out what I put up on our Canvas site and add to it and have one sheet. Because literally, sorry, hit the wrong button. Literally, I use this sheet all the time. See, I've written on it, so instead of having multiple sheets, I have sides. I kind of copied our little table of key values of sine, cosine, tangent, and then here are all the formulas. So literally, chapter 4, we use this sheet, and that would be the reference sheet. So I'd recommend you making that. Like I said, if we were together, I would hand them out because I could use the copier at Harold Washington. Okay, so let's end with a bang. And what I mean by that is this problem is hard. And so what I'd like to do is one that is, I think, super challenging, and it's going to incorporate a bunch of these ideas now that we've introduced in concepts and identities and equations. And here it is. And to be honest with you, when I got this out of the book, it took me 2 tries before I got the right answer. The first time I went down a path that did not work, and the second time I did. So it's a very challenging one, especially now we have so many different formulas that we have to coordinate to figure out what to do. And to be honest with you, it is a challenge. So you look at this and say, the first thing that I did when I looked at this is I said that sine of x and cosine of x, if you look at the double angle formula, that actually is sine of 2x divided by 2. And I started down that path by that substitution. But then it didn't lead me anywhere because once I got the 2x, it didn't really help me because I got 3x on the top. And what I'm trying to do is to get cosine, and then 1 over sine is sec, or 1 over cosine is secant. So I was like, So I tried that, and I was like, I didn't know what to do after that. So the next thought I had was, let's take sine of 3x, which is up in the numerator, right? And write it this way. Sine of 2x plus x. And why do I want to do that way? Is now we can use one of these crazy formulas that we have. And this was back at the sum and difference. Or I think the book called it the addition subtraction formulas. Obviously, those are synonymous. And so in this case, when you set that up, our new numerator would look like this. So the sine of 2x, which is the first term, then cosine of x, and then it was plus cosine of 2x, sine of x. And I said, ooh, that's getting me in the right direction now, because here's what the new equation looks like. I'm like, ooh, there look like there could be some cancellations, right? So let's look at this. Sine of x, cosine of x. And so now you look at that and say, not quite. So what do we need to do? Well, those 2 x's need to go away, and we need to do something with that. Well, that's the double angle formula, right? So if you look at the double angle formula, let's do the double angle formula. For sine and cosine. And here's where the real challenge is. So again, I'm just going to focus on the numerator right now. And so the sine's pretty easy because that's 2 times sine of x cosine of x. So when you do that substitution, it looks like this. That's this equals that. And so now we still have a cosine of x left. You're like, oh, look, we can do a cancellation. We're getting in the right direction. I was like, so the next step is, what are the 3 formulas that you want to plug in here to get rid of that? Well, if you look at those, first one's cosine squared, sine squared, minus sine squared. That's like, no. Then we have sine cubed again, and the cancellation doesn't look too good. So the other one has 2 cosine squared of x minus 1. And you're thinking, still not great, but you see you have a cosine up there, which is a good thing for this cancellation. And then the other one has 2 sine squared in it, which won't work. So the one that you want to use is 2 cosine squared of x minus 1. That is the formula, and then you multiply it by sine of x. So let's see what's left after we multiply this all out. So we have 2 sine of x, cosine of x, and then another cosine of x. And then we have plus 2 cosine squared of x, sine of x, minus sine of x. And you can see that this and these are the same. Look, cosine squared, right? So we could have wrote that cosine squared up here, right? So these two terms are the same, and so it ends up being 4 cosine squared of x, sine of x, minus sine of x. So again, that's just on the top, right? But see what happens when we put our denominators back in. Sine of x, cosine of x over here, and then sine of x, cosine of x over here. So you see this cancels with this cosine gets rid of 1. And so what's left on our first term? 4 cosine of x. Ooh, we're in the right direction, got half of it. So what happens here? Well, this and this cancel. So you're left with minus 1 over cosine of x. And what does that equal? Well, by those basic identities, right, that would equal secant of x, QED. So I thought it would be good to end with a very challenging proof. Oops. To kind of show everybody what this process looks like and something that's reasonably complicated. So hopefully these recorded lectures are helping. And so that finally ends section 4.3.